Well, no copy, no get back on Evel Knievel. No copy, no get back on Evel Knievel. 388 Big Bear Mountain, Southern California, with the bamboo quad pointing east and listening.
Come on, 380. Come on, 380. Evel Knievel. Chicago. You hear me, Greg?
Hey guys, welcome back and thanks for tagging along for part 2 of the CPI CP2000 accessories video. And best I can tell, this DM1, DM standing for deluxe microphone, was an accessory. So before I go any further talking about the CPI DM1 microphone, I just want to make sure you guys are well aware of the pinout connections required to properly operate one of these CPI radios. They use a floating ground, much like recording studios do, with a dedicated shield. It's extremely important you get that right on these radios, or you're going to find yourself inside replacing a very hard to access, very sensitive, easily damaged by static field effect transistor. As far as sound quality of the DM1, if you watch part 1 of the CPI video, you probably already heard the on-air live comments. But I will say, I'm usually heard on a high-end tube radio, and every time I key up this CPI, I'm using this DM1 microphone, although I have tried others on here. This microphone really sounds wonderful, and with the FET preamp, it is very loud. Run at about a number 3 on the mic gain, and just box stock radio. Is it sounding okay?
Sounds excellent, man. Clean, nice, solid, got audio. Little nice, full range of the audio. Signal's good. Sounds really good, that you for.
Okay, guys, here's the BC2000, what I consider a really action-packed accessory to pair up with the CP2000 base station radio. As you can see, this is a frequency counter. This frequency counter came about at a time when it was considered a real luxury to even have a digital display on an amateur radio. It's got a 2-position antenna switch. It's got an antenna tuner capable of handling 400 watts, and it's also got a very functional receiver preamp, as well as a 12-hour and a 24-hour military standard time clock, which was actually a useful accessory back then, as a lot of react monitors, I know for a fact the Great Lakes Coast Guard was monitoring 11 meters. So having a 24-hour military standard time clock was actually a useful accessory. So here's the back of the BC2000. The hookups are pretty straightforward. We've got this AC cord plug in here. We've got a 4-pin low voltage Molex connector in case you want to run mobile operation. We've got these 3 slide switches here for programming of the clock. We've got the antenna switch here for antenna number 1, antenna number 2. This is a great feature. It's a nice high quality switching network inside. You could be running a vertical such as IMAX on antenna number 1, a horizontal beam on number 2. That's pretty neat. Here's where your transceiver plugs in. This is where you will hook up the cable from the CPI to the BC2000 to enable the frequency counter, and this is an RF sample out that you could hook up to an oscilloscope or something and monitor a waveform. So once again, a really nice, well thought out, action-packed device. Now, as you can see, fine-tuning the sideband signal or an AM signal actually moves the frequency counter. This frequency counter actually does sense the circuitry within the radio. So here's a wonderful feature of the BC2000, the antenna tuner function. This was an extremely important feature back in the day. We were stricken to 23 channels with a maximum transmitting frequency of 27.255 megahertz. A lot of antennas were fairly narrow banded back in the day, and once people started being able to go up to 27.405, channel 40, they started showing SWR. Now, once again, I've got the antenna tuner switched off. We're going to go over here to the CP2000, and I've got it in the calibrate mode. We're going to check calibration of the SWR meter. You can see that it is calibrated. So now let's go ahead and look at the actual SWR with the antenna tuner switched out. Holy moly, showing over a 1 to 2 SWR match. Now I'm going to go ahead and flip the antenna tuner on. Look at that, almost flat. Now I'm going to dial it down even lower using this tuner. Most of today's better modern amplifiers have what is known as a tuned input, keeping solid-state transmitters happy when looking into the amplifier. But for those that don't have a tuned input, which is about 90% of the older amplifiers, a device such as an antenna tuner is a real handy device and can really maximize forward swing as you're keeping your transmitter happier by having an antenna tuner employed. CPI has also built a wonderful television interference filter into this, as well as the base station console, providing even further harmonic attenuation. They've got a wonderful receiver preamp function on here. Got the receiver preamp in the off position right now. There, I flipped it on. You can see a little bump in the S meter. I'm hoping we can get some weak signal stations here. There, I've just turned the preamp on. Off. On. Receiver preamp off. As you can see, this receiver preamp is quite useful, provides a nice boost in received incoming signals, yet doesn't amplify white noise like so many of the lesser receiver preamps tend to. So here's the top side of the BC2000 with yet another wonderful circuit board designed by CPI with a very functional circuit flow, greatly helping the ability for one to troubleshoot should that need to occur. We've got a fairly substantial power supply here with some humongous 3-amp rectifier diodes, a rather large filter capacitor, and that was absolutely essential to feed this power-hungry TTL, also known as transistor logic. This was state-of-the-art technology back in the day. And you'll also see we've got a 2-amp glass fuse hidden under what used to be clear tubing here. Okay, this is the underside of the BC2000. I want to start by showing you this TO3 case transistor. This is the voltage regulator that provides the 5-volt supply to the very power-hungry TTL circuitry I was talking about. These are the engagement and disengagement relays for the receiver preamp and all the adjoining circuitry here. We've got 2 IF coils for peaking the receiver preamp circuitry, and then we'll move on to the antenna tuner section. Even though the BC2000 antenna tuner is rated at 400 watts, my advice is don't go there. Palstar makes an auto tuner for the amateur radio crowd that's rated at 10,000 watts. Are they worried an amateur radio operator is going to throw 10,000 watts into their antenna tuner? No. When initially tuning into an extreme mismatch, these air variable capacitors endure the forces and strains of much more than the actual wattage being fed into the tuner circuit. And the last thing you want to do is arc these air variable capacitors. It's pretty much game over when that happens, as a phenomena known as carbon tracking occurs. Carbon tracking is the electrical equivalent of cancer. Once it's there, it's almost impossible to get rid of, and that is the biggest problem with both manual and auto tuners, is people overpowering them, causing arcing, which creates sparking, carbon tracking, and it's a problem that only gets worse. And for those of you that are considering or actually own one of these and doing capacitor replacement, if you saw my first video on the CP2000, mentioned there were some electrolytic capacitors hidden under the IF cans. In this case, yes, there is one hidden right under that IF can. Other than that, you're good to go. Let's have a look at the CPI WM1000 combo meter inside and out. And I think you're going to like what you see on the inside. Anyways, as you can see, we've got three nicely illuminated, very large meters that can all be read simultaneously. Now, the hookup of the WM1000 is pretty straightforward with the exception of one peculiarity. This device requires a 9-volt battery, and then if you want the meter lights, you need to have an either AC or DC voltage applied to these two terminals. Applying voltage to these terminals does not get the meter electronics working. Applying voltage to the meter electronics does not get the meter lights working. Let's have a closer look inside the combo meter. This is known as a line section. It contains the RF sensor, which is connected to the circuit board through some laboratory-grade coaxial cables. It's housed in an RF-tight enclosure, strategically located right next to the SO239 coaxial input and output jacks. You'll also notice a set of 4 trimmers here. This is the calibration for the 20-watt meter scale. This is the calibration for the 200-watt meter scale. This is the calibration for the 1,000-watt meter scale. And then we've got a modulation calibration back here as well. You'll see that I've recapped it. I've got both the 9-volt battery hooked up for the meter's low voltage supply, and then I've got a 12-volt AC supply. Both of these functions are turned on with the power switch. Let's see how it stacks up to a Bird 43-watt meter into a Bird Tourmaline resistive dummy load. Got a 10-watt slug in. I'm running this meter in the averaging mode as well as the WM1000. I'm going to go ahead and key up the CP2000. No audio. You can see we're reading 4.5 watts. Don't be alarmed. I can easily peg out a 25-watt slug. These CPIs got plenty of horsepower, but I've got it set up to factory spec. So we're at 4.5 watts on the Bird 43 going into the RF termination, 50 ohm resistive load. And you can see I'm whistling just shy of 8 watts. Okay, let's see what we've got on the WM1000. We're showing right about 5 watts. I've got it in the averaging position on the 20-watt scale. And reading a bit over 8 watts. Not bad considering a CB watt meter versus a commercial Bird 43. And the accuracy is about the same on the other scales. So my overall assessment of the WM1000 watt meter, yes, it's a very nice accessory. So in closing, I give the CPI WM1000 combo meter very high marks for a level of electronic sophistication never seen in test equipment geared towards the 11-meter crowd. It's got large, illuminated, easy-to-read meters that are all fully functional simultaneously. It utilizes some very sophisticated electronic circuitry, ensuring a very accurate and true reading of peak modulation percentage and peak RF power output. Just a wonderful physical execution. Like everything CPI does, you get what you pay for.